And welcome everybody. This is the last video for chapter 9. We're going to be discussing the distribution of sample proportions. Okay. Um, excuse me. In the last video was the distribution of sample means. This is the distribution of sample proportions. If we recall, the formula for any proportion is p hat, which is the sample proportion, is equal to x over n. Okay. How many you have divided by your sample size. Okay. Um, some criteria for the sampling distribution of p hat. The shape of the sampling distribution of p hat is approximately normal, provided that n times p times 1 minus p is greater than or equal to 10. The mean of the sampling distribution p hat will be the same as whatever the population proportion is. And the standard deviation of the sampling distribution p hat is given by this formula, the square root of p times 1 minus p over n. Okay, so let's work this problem. According to the 2008-2012 American Community Survey by the U.S. Census Bureau, 70.2% of Kentuckians that were born in the U.S. were actually born in Kentuckians. In other words, 70.2% of Kentuckians were born in Kentucky. They're native Kentuckians. Okay, and we have some problems that we'd like to work on this, but first we need to check our criteria. N times p times 1 minus p must be greater than or equal to 10. Now, again, we do not use percents in math problems. We always change them to decimals. So in this case, n is going to be equal to 450, okay, that we see right here. P, the population proportion, will be equal to 0.702 that we see here. Okay, so this is going to give us 450 times 0.702 times 1 minus 0.702. That needs to be greater than or equal to 10 in order for us to work this problem. So let's go to the calculator here. If I do 450 times 0.702 times 1 minus that amount, okay, I end up with 94, and 94 is clearly greater than 10, so we can work this problem using the method that we've described here. So it says, what is the probability that 75% or more of your sample will be native Kentuckians? So we can do our normal distribution. In the middle, we've got 0.702, and they want to do 75% or more, so 75 is going to be on this side. It'd be 0.75. Or more of your sample. So it says or more, so we're shading up. Okay. And really, we can just go straight to the calculator here. And we're going to say that second distribution, normal CDF, the lower bound is 0.75. The upper bound is infinity. Mu in this case is 0.702. And the standard deviation is the square root of, parentheses for the numerator, 0.702 times, parentheses, 1 minus 0.702, close parentheses for the numerator, divided by 450, close parentheses for the square root. Okay. So, let me check my math here. Just checking my square root. So 0.702 times open, open, parentheses, close, close. Okay, looks good. So we end up with a 0.0129 or 1.29% chance. Okay. In the second problem, we're doing 65 or less. So we've got our normal distribution here. Here's 0.702, 70.2%. 65 or less, 65 is going to be on this side, so 0.065. And it says or less, so for less than, we're shading in this direction. Okay. And again, we can pretty much just go straight to the calculator. So second distribution, normal CDF. The lower bound here is going to be negative infinity, so negative 99999. The upper bound will be 0.65. Mu in this case is still the same. The standard deviation is still going to be 0.72 times 1 minus 0.702 divided by 450. Did I miss a zero in there? No. Okay, I'm good. And then paste. Enter. And 0.0079. Or 0.79%. Okay. All right. And that should be the end of your notes for Chapter 9. If you have any questions, again, please email me. You can send me homework questions, and I'll be happy to respond as quickly as I can. Everybody have a great day.